Okay, so you guys gonna have to move seats.
Oh, man. Sitting right here. Just like, sit back.
Okay. So we're gonna start record a section, so you guys still can shout. I don't really care about my YouTube channel. DJYUF. So we're gonna talk about few rules. We're gonna start with simple limits. Limits as an x approach to C of B is equal to B. That's a pretty easy one. We're going to talk about second one as well. Limit x approach to C of x. What do you think it is? X. Okay. Limit x approach to C of x to the n is equal to C to the n. Okay, so those are the things that we're going to go through. And you say, yes, that's kind of confusing, I understand. And so this is three different ones. But you say, well, what does that mean? Well, what is B? What do you think B is?
A function.
Actually,
Constant.
it can be a function. It is a constant. Good, it's a constant. Limit x approach to C of B is equal to B, so it's a constant. So what if we take example, why is that? What's the difference between those two? There was a slight subtle difference. You can see it. So you say limit as an x approach to 4 at 8 is equal to what? 4 or 8? Multiple choice.
8.
Is that 4 or 8?
8.
8. Why? It has to be a proof, right? It has to prove something. So instead of memorize this, on the test, are you actually going to memorize this? I don't, because it's kind of confusing to memorize. So how do you prove it?
You draw it.
You draw it. Good. So you draw it. So you draw a function, and the function is going to be 8. So we're going to say 8 here, and then we're going to draw a function y is equal to 8, right? So I'm approaching 4. What is my y value? My y value is still 8. So that's why this one is 8, not 4. But a lot of people think it's 4. But then this one here, limit as an x approach to 2 of x, right? Then you say, well, this one's what? 2. Because if you draw it out, the x function is going to look like this. Right? This is the x function, y equal to x. And if I approach 2, this value is also going to be 2. So that kind of makes sense. Because that x and constant are different type of lines. Okay, one is a flat line, one is a 45-degree lines according to the origin. Now, last one is self-explanatory, just substitute in, and you're going to get an answer, and you're done. Okay, question about this part. Okay, next part. So this is a pretty easy part. So we're going to go to the next part. Next part it says, hey, can you go, is there any rules that you know? So we're going to say let f of g be function of this. F of g, this is x. Be the following. limit x approach to c of f of x, we're gonna call this equal to function L, constant L. And limit x approach to c of f of x, g of x is a function k. So I'm gonna write a capital K. So those are like directly coming from textbook. It's pretty intuitive. So what if you have limit x approach to c of b f x? Well, again, b is what? Constant. So can I take a b outside? Right? So it's gonna be b limit x approach to c f of x. So we know limit x approach to c of f of x is gonna be L. So it's gonna be BL. Questions? Now we're gonna go to the next one, sum and difference. So if I have limit x approach to c of f of x plus minus g of x, that's gonna be what? F of x plus minus. It's gonna be what?
L plus minus K.
L plus minus K. It's very intuitive. Same thing of L x approaches C of f of x times g of x. That's gonna be L times K. And limit x approaches C of f of x over g of x is equal to what? L over K, but with one condition.
G of X.
Huh?
G of X is not equal to 0. Well, like A doesn't.
K does not equal to 0. The last one is gonna be power rule. So f of x to the limit x approach to c of f of x to the n power is equal to L to the n, and that's pretty intuitive. So beside the first three basic limits you need to know, and that's pretty intuitive. Questions? And last one's a composite. So you don't need to know the true theorem, but we're gonna write it down here, so just in case. So if limit x approach to c of g of x is equal to L, and limit x approach to L, x approach to L, f of x is equal to f of L. Therefore, limits x approaches c of f of g of x. That means f of parenthesis limit of x approach to c of g of x is equal to f of L. Which just makes sense. It's very just put inside and outside, and then that's it. Okay, so that's the first part of the notes, just to understand some properties. Okay. Then we're gonna say, hey, let's go to the actual limits. So remember, we had that question over there. We're gonna deal with that question later. But we're gonna start with some simple questions, but we're gonna talk about how do we evaluate a limit algebraically. There are a few ways and there are a few situations, and we had to take account to all the situations. So we're gonna go to next. Can I erase it or no? Okay. You guys can always watch the video if you guys miss. But this is not an important part. This is a very intuitive part. Intuitive. Okay, so now we're gonna evaluate limits. We're gonna evaluate limits, not like yesterday, plug in each individual numbers. Although that's one way to do it, you plug in each individual number to get there, to get closer, 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 closer. But there's gotta be a way to do it algebraically. So how do you do things algebraically? So let's start with find limits algebraically. How to spell algebraic? Algebraic.
That's perfect.
L-Y?
The R.
It's
hard.
That's it. Yours. Close parentheses. There you go.
It's not how to spell it?
No.
That's pretty good, that's pretty good.
That's practical.
Okay, whatever. I'm gonna embarrass myself in front of the world, and that's all that matters. Okay, so find the limit algebraically. There's things that limits. If you want to evaluate limits, you just plug in the values. So, for example, if I have says, so first thing is just plug in a value. So plug in the x value, and that's what you're gonna plug in. For example, we're gonna do an example here. So limits as x approach to -2 of x squared minus 4. So what do you think the answer is? Somebody? It's 0, right? So just have to plug in -2 squared minus 4 is equal to 4 minus 4 is equal to 0. So that's pretty easy. But what if you plug in a value and you get something like a 0/0? Now in the past, we learned that something over 0 is undefined. But we never learned if it's 0/0. Remember, we didn't know what 0 to the 0 power is. It's 1, we prove with limits. But we never understand, what if you get 0/0? 0/0 is we call the indeterminate form. Okay? So this case is called indeterminate form. I have no idea how to spell that, but indeterminate form. Whatever. Okay, so indeterminate form means you don't know what a value equal to, but you can do some type of math to it. So if you get 0/0, what you're gonna do is you're gonna do math. Duh. What kind of math? Well, there are 3 different kind of math, 3 different kind of situation. So first situation is factor and cancel. So you can factor something, cancel some factor, and plug it back in. 2, if you see radicals present, usually means you gotta deal with some type of conjugate or rationalize. So rationalize. 3 is combined fractions, which is, that's what we've been doing from 2 days ago when we deal with complex fraction all the way in the back. We got some complex fraction over there, and we say combined fractions. Questions about those 3 things? We probably like, well, how in the world do I apply? Okay, so what if you got limit x approach 2 of x3 minus 8 over x minus 2? What happens if I plug in 2? 0/0. I'm gonna do math. Devin, you need to wake up because I'm going over and you don't forget. I'm gonna see what happens. I cannot do that in front of the whole world.
You can see it behind the scenes.
I had to do that here. And come back, acting like normal. Okay. So now this is the next day you give me fire and I don't have a job. You're gonna have a substitute for the rest of the year. Good luck. Okay, so lemma x approach 2 of x cubed minus 8 over x minus 2. So you say, hey, if I plug in 2 in there, so it'd be 2 to the power minus 8 over 2 minus 2, that's equal to 0 over 0. So you say, hey, I don't know what happened to this, but this is 0 over 0, I don't know what happened. So you say, hey, let's factor it. Do you guys remember how to factor the cube? It's on my review sheet.
Parentheses x minus 2.
So how many of you guys know how to factor the cube?
So
We talked about soap, right?
Yeah.
So what is the equation? A cubed plus minus B cubed equal to A plus minus B times A squared minus plus AB plus B squared. You guys remember this?
I remember.
You guys, yes?
Yeah.
You guys like,
I remember the
yes?
first part, the A plus or minus.
Yeah.
Okay, so this
Yes.
part I'm gonna remind you, same sign as before, actually complete the same without the exponent. The second part is what? Opposites? No. I really wanna say something, but I cannot say.
I know what you
That's a digital proof. I don't want to do that.
Pause it.
I can pause it.
Okay, opposite, and this is always positive. So it's always positive. So that's how you utilize the sign. And most of you guys don't remember what happened here. A squared, B squared. Just kind of know the Putnam square. A, Miss Cohen's class. B. Oh no, not AB. And that's gonna be A, right, A squared, and this one's gonna be AB, and B squared. The only thing you have to cross out one, you just need to find out how many different blood type you're gonna get. You're not trying to find a percentage of which blood type you have.
Thank you, scientist.
Yes.
Chemistry.
On chemistry degree.
Teach physics.
I'm gonna teach Chinese next year. AP Chinese.
Miss Yale joined the class.
Yeah.
Konnichiwa.
So. Konnichiwa. It did not happen. And one day I was in the Florida Mall, and I went to walk by, and there's a Rosetta Stone, and Rosetta Stone trying to solve the language, and I teach you how to learn new language, right? And the guy's coming to me, he's like, no, you want to learn new language? And I said, no, I don't want to learn new language. He's like, no, are you Chinese? I said, yeah, I'm Chinese. I said, I know how to speak Chinese. So the guy trying to sell it to me, right? He said, I know how to speak Chinese. Look at me, konnichiwa. And I turned around and walked away. I was like, oh my God. This is actual thing. It's true story. It's for them all. So, x cubed minus 8. Can somebody help me factor if you know this?
X minus
X minus 2.
X minus 2.
Parentheses x squared plus 2x
8x.
plus
2x.
4.
What happened when you had 0 over 0? Because what happened, you cancel this, it's not gonna be causing 0 now. Right? So now you can plug in the 2 back in. So you're gonna say limit as x approaches 2 of x squared plus 2x plus 4. That's equal to, well, plug in 2, so it's gonna be 4 plus 4 plus 4. That's equal to 12. So the answer is 12. So this is a factor and cancel, but I cannot teach you how to factor. You guys should know how to factor by now because you guys go through the first week torture. You should know how to factor by now. Difference of a square, factor by grouping. Everything is a fair game. Any type of factoring is a fair game because they are algebra. Can give you a 4-term polynomial. Maybe long division. That'd be cool if they give you long division. That's a good idea.
No. I already forgot how to do that.
Okay, so it's something you can factor this. So, any questions? So we're gonna talk about the second one, which is radical conjugate rationalized. What does that mean? Which is questions on the other side. So can I erase this part and then work on this part? So this one you already have it on your notes, right? So it's on the internet, yeah. Okay, so now we're gonna say, hey, let's do that. This is a cool question. This is actually one of the cool questions that I see. -6 square root of 10 minus x minus 4 all over x plus 6. This is such a cool question and it's such a cool way to do it. So then you say, okay, let's do this. So let me ask you about algebra questions. What's conjugate mean?
Something that cancels out to 1 over 1.
Okay, so Mamon, what's a conjugate mean?
You gotta do the opposite of the thing. You just put the thing with the opposite sign and you just do it over that. You understand what I'm saying?
No.
Well,
Educate me.
that's how I did it on honestly.
Cool.
How to do it.
I don't know how to explain it.
Okay, so you're gonna multiply something called conjugate. You're trying to rationalize. You're trying to rationalize because it was radical. But you guys never heard that you had to rationalize the numerator. Because usually we rationalize the denominator, right? We never rationalize the numerator. It turns out it doesn't have to have a radical and denominator. There's no such a thing as like you cannot allow have radical and denominator. You can have answer with radical and denominator. It's just not simplified all the way, but it's not wrong answer. It's like 2 over 4. It's not wrong. It's supposed to 1 over half. But there's actually no such rules. I say you have to only rationalize the denominator. You can rationalize the numerator as well. But let's talk about how do we rationalize the denominator in first thing. So let's say 2 minus square root of, let's say, square root of 6, something like that. So we say, how do I rationalize this? We're gonna multiply by
2 plus square root of 6.
2 plus square root of 6 over 2 plus square root of 6. You have to multiply by 1. Okay, so this part is gonna be a minus b, a plus b. So what happened when a minus b times a plus b? So that's how you get rid of radicals, right? So that's equal to, on the bottom it's gonna be what? 4 minus 6, right? On the top it's gonna be 4 plus 2 square root of 6. And a lot of you guys don't know how to simplify this. 4 plus 2 square root of 6 all over 2. Can you simplify this? Huh? Oh, -2, thank you. So, how do I simplify this?
You split it. 4 over 2 plus 2. You gotta split that.
You split this, so it's gonna give you -2 plus minus square root of 6. Don't just cancel this because you kill penta, I think. Okay, so now we're gonna go to here. We're gonna say erase. Can I erase this part? This is algebra 2. How do we do a calculus problem? So what are we multiplying this? The same thing. It's called conjugate. Square root of x, 10 minus x. The guy's talking to me.
Basically, plus 4.
Plus 4? Oh, thank you. It's conjugate, so it has to be the opposite sign. And the reason why it's difference of the square, when you FOIL difference of square, it's going to become a squared minus b squared. So this part will cancel out. 10 minus x minus 16. Limit x approach to -6 over x plus 6. And you do not want to FOIL the bottom because that's nasty. Alright? So that's 10 minus 6 is what? X approach -6 is going to be what? -x minus 6, right? Hold on, I haven't finished yet. I need to go through one more example, sorry. Plus 4. Then you're going to factor out a negative sign here. So that's going to be x plus 6. And then you plug in -6 in here. So it's going to be -1 over square root of 16 plus 4. That's equal to -1 over 8. That's wonderful. Okay? I'm going to go over one more example. Sorry. Or you can watch a video. Fine. I'll just go over. Any question about this part? Okay, so we're gonna go over last one, combined fractions. Just try not to create too much noise while you're working out combined fractions. It's pretty easy, just have to combine them, and you're gonna get answers. So you can go. I'll just record it. So here's the last part. The last part says lemma x equals to 0 on here. They're going to get 1 over 4 minus 1 over 4 over 0, which is 0 over 0, which is undefined. So you see two fractions, that's what we learned from before. We can combine those two fractions together, right? So I'm going to multiply this side by what? 4 over 4?
Yeah.
I'll multiply this side by x plus 4 over x plus 4. So then I will have limit as x approaches 0, and it's going to be 4 minus x plus 4 all over 4 times x plus 4 and all over x. I'm going to simplify this, so it's going to be limit as x approaches 0. 4 minus 4 is going to go away, so that's going to give you a negative x over 4 times x plus 4. Now since this divided by this is divided by x. So the top fraction divided by bottom fractions. So divided by x, I can change that. X over 4 times x plus 4 to 1 over x. Limit x approaches 0. X cancel out. Now that's going to be equal to negative 1 over 4 times 4, so it's equal to negative 1 over 16. So that's the last case. Okay, and that should be all. Sorry, I ran out of time, but I recorded. This is proof. Okay, any questions?